All right. Welcome to Daswon Hunt. I'm Jab here, Ruth, for Information Week. And in this episode, we'll be taking a look at what will be, or potentially could be, quantum computing's role in the cloud. We've had different players from the cloud side kind of starting to kind of dip their toes into the quantum side of things, developing chips or other elements in this, but trying to get a grasp on how this interrelationship might play out with both formats, both elements of technology being developed, and further how that might grow together, potentially intertwined or parallel to each other. And in this episode, we are joined by James Kaplan, partner with McKinsey, Rich Salz, principal architect at Akamai, Matthew Keesan, vice president and general manager of quantum computing and platform for IonQ.
Howdy.
And Daniella Pontes, quantum ambassador. All of you. Thank you so much for being available today for the show.
Our pleasure. Thanks for having me.
Glad to be here.
Okay. All right, James, to start off with you, a lot of attention that surrounds quantum computing typically ties to, the talk of potential upheaval in regards to cybersecurity. How much of that, if any of it, includes security in the cloud? Can quantum computing make the cloud more secure or less? Or is really that kind of like the wrong question to kind of really be directing towards this?
Here's the way I think about it. There are breaches in the cloud, but they're almost entirely the result of misconfiguration rather than a technical compromise of the underlying service. So in order to be secure in the cloud, you need to configure appropriately. And most people are at least trying to do that via security as code, where they define a set of policies and use, say, for example, cloud security posture management to make sure they're enforcing their policies for the configuration of their cloud systems. Clearly, the imperative for security in a post-quantum world would be about quantum safe encryption. You need to find ways to use quantum safe encryption techniques. The interesting intersection of the cloud and quantum safe encryption is if you're using security as code, right? Then what type of encryption becomes a configuration decision, because the cloud providers will over time offer more and more sophisticated quantum safe encryption capabilities or services that you can leverage, as opposed to having to go pull out modules, refactor software for systems that you're running on premises and which you haven't defined as code. So I think increasingly over time, people will need to continue to put in place security as code for their cloud environments, and then over time, start to leverage quantum safe encryption capabilities that will be offered in the cloud as a way of protecting themselves from quantum enabled threat. Now, there's a lot there, because you do need to managing systems as code requires some degree of change and a fair degree of often refactoring existing applications.
Gotcha. I appreciate your insights on that. Thank you so much. Matthew, could the cloud lead to democratization of access to quantum computing? And with that, does industry want widespread access to quantum compute power going forward?
Yeah, absolutely. IonQ is the only quantum computer available on all three major clouds in the US, Amazon, Microsoft Azure, Google Cloud, precisely because we believe democratizing access is a huge accelerator of the overall quantum economy. I mean, just think about classical computers. They used to be huge, expensive, used by a very small group of scientists, universities, large companies, militaries trying to break encryption, if that sounds familiar. And now billions of people have computers in their pockets, and a teenager can ship an app that could change the world overnight, right? That democratization of access to classical computing completely changed our ideas of what computers could be and what computers could do. Similarly, for quantum, we already know of applications worth hundreds of billions of dollars, but that's probably just scratching the surface, because only a handful of folks are really researching novel algorithms today. Creating access for more people means new discoveries, new applications for businesses, and growing that overall economy. And we definitely see CTO offices I think in every Fortune 500 company are starting to think about how is quantum computing going to affect my business, and the cloud is a great way to start working with it.
I appreciate your input on that. Rich, could quantum computing add to the overall cost of cloud computing, and which might give there's still some cloud naysayers out there another reason to be reluctant to then try to leverage the cloud?
Sure. So it needn't. We've discovered when we're starting to scale out and do our post-quantum work that the incremental cost for the basic post-quantum protection is kind of in the noise. It doesn't matter a great deal. Now, that doesn't mean that somebody won't say, oh, we can do an upcharge for this new feature, because that's the way commerce works. But I think we're going to see, just as private communications, TLS, became table stakes and that everybody has to offer it or use it, we're going to see increasingly over the years as particularly the U.S. government requirements for scheduling, 2035 deadlines and stuff come up, that quantum safe communications are going to become table stakes. And so while there might be an initial burst, I would expect over time it's going to get commoditized. And we've also seen, as I said, we've seen that it's not a significant increase in CPU cost. So the long trend is definitely commoditization and table stakes for being quantum safe in your communications.
Gotcha. Very much appreciate your thoughts on that. Daniella, should enterprises make an effort to be quantum ready, AI ready, along with cloud ready or cloud native? Could this be also be a point of confusion for CIOs and others in leadership trying to be all ready for all these different elements?
Definitely. It's not an option to not be ready for quantum, both from a cybersecurity perspective, but also from a competitiveness kind of perspective. Yeah. Quantum is such a, I would say, revolution in technology and so profound that will impact everything. So from being ready to be safe in the quantum era, you need also to not just look inside of your own environment, but start asking your partners, people that you have technology relationship or business relationship, to understand what they are doing. Go to the cloud and see how they can make you crypto agile. Yeah, so you can do that transition to a quantum safe environment, and ask what they are doing for themselves to make sure that the underlying infrastructure is actually quantum safe. And there is a transition in terms of educating your own personnel, your teams to understand the potential of quantum from these two perspectives. And from a technology that will open up, opportunities for cost savings, for being more efficient, to address new markets, so be more competitive. That is a no-brainer. Yeah, you do need to have that perspective. And for the CIOs or the C-level executives, they need to start, looking into this and making sure that they create a team in their company that are trained and understanding the benefits and the threats of quantum computing.
Gotcha. Great. Thank you very much. I appreciate your thoughts, and I appreciate all of your individual insights on those questions. Okay, for all of you, let's get this out there. Is cloud a distraction? Kind of like in this kind of conversation, is it a potential distraction from uses that quantum computing, the so-called real uses quantum computing could be focused on, or are there really complementary things that cloud can offer to the further development and furtherance of quantum computing?
I would say it's a launch pad. It makes early adoption so easy, right? If we think about the beginning of computing, right, you needed to build a special room, hire all sorts of people to come run your computer. Now we have the cloud. People can click a button on Amazon Web Services, on Azure Quantum, on GCP, and run their first quantum experiment right now, right after listening to this podcast. That makes it accessible without large investments. So for folks in the CTO or CIO's office who are just starting to think about that quantum roadmap that we were just talking about, that level of access, I think makes it so much easier to start understanding when is quantum computing going to intersect my business problems? When do I need to be ready?
Exactly. And also, quantum will not be a replacement for everything. Yeah. And it will coexist with the classical infrastructure that we have for storage, networking, and the cloud is an environment that offers this in an elastic form, orchestrated form. So you can do those experimentation, get your workforce trained and investigate simulations with the cloud environment without, these entry barriers of, having a whole quantum computer in a data center.
Yeah, I'm skeptical, but I will say that, it's not surprising that almost all of the major cloud providers in the US have recently announced new quantum chips, right? We saw that in the previous version with everybody announced their new AI compatible chips and platforms and virtual images. And so now we're seeing, oh, well, it's starting in the cycle where we have a quantum chip, and soon that will be, you can probably order your virtual image with so many quantum chips the way you might now order it with so many LLM compatible, video chips. So I think it's likely to come. These folks make good business decisions, so they're expecting a marketplace for it.
Gotcha. All right, appreciate your insights, all your insights on that. Speaking of quantum chips, let's talk about that. As you were just mentioning, quantum chips developed, like you said, by players in the cloud. Are there more ways that providers and players in the cloud, will be further involved in the development of quantum computing beyond the chips aspect?
I could take that. It's already a huge enabler of everything, right? And many of the world's largest companies today are already accessing quantum computers via the cloud. And as we were just talking about, we expect as quantum computing scales that quantum computers will be like an accelerator for certain problems, not the be-all, end-all, but rather there will be hybrid heterogeneous compute, GPUs, CPUs, QPUs, et cetera, all working together to solve problems. And having that be elastic in the cloud, as Danielle was just talking about, makes it incredibly convenient for users to spin up in the cloud and run their program. Just as today, like the cloud providers are already a platform that others build upon, right? Folks are building applications in the cloud to enable new use cases. That scale that they have means it's so easy for any developer to take advantage of this new technology.
Exactly.
Two thoughts on that. One is the advantage in cloud for quantum is probably in certain respects more significant on a per unit basis than it is for traditional compute, right? x86 CPUs are relatively inexpensive and not that power dense compared to, for example, quantum processing, so that, it will be probably uneconomical for most enterprises to try and maintain that type of infrastructure on their own. First thing. Second thing is, there will be probably a lot of experimentation about different types of use cases. For example, are there types of route optimization you can do with quantum, or even sort of compute network, or network optimization you do with quantum that will be impractical using classical computing? Latency and timing to has been a barrier to blockchain adoption. Could quantum compute change the dynamics there? And then certainly I'm sure there's a few people trying to think about whether quantum might be relevant for inferencing for Gen AI, for large language models.
The cloud can facilitate a lot in terms of providing frameworks already there for you to just, call as a primitive. So as was mentioned, it can easily make the transition or the usage of quantum technology easier to adopt. And on top of that, cloud is nothing but a network of resource there, and quantum will also impact communication, network communication. So they will play a big role also as we move towards, for example, a quantum internet. So there is a lot of touching points and cooperation that the cloud providers will have in bringing this whole industry to life.
All right. So let's take it a little bit further. What does cloud use do? Like the folks of development on the cloud, what does that and the technology that's running in the cloud, what could that bring also to the quantum compute space? As we're trying to, further see the cloud evolve, what could that mean for how quantum might further evolve itself?
I think it's really the themes we've been discussing, right? The cloud brings scale, it brings connection, and it brings value-added services even. So, for example, if you wanted to get on the web in the 90s, right, in the birth of that technology, you really needed to be at the forefront, and a lot of companies missed the boat, right? But now we're all on the internet. Everyone can watch this technology mature in public, right? We all can see it globally. And that means that the access and connection, the hub for research and development, both supporting experimentation as well as production workloads, that ease of access just lowers the barrier to entry to almost nothing, right? Just a small budget, right, to get started. We already see quantum research communities, from university communities to Fortune 500 communities, all working on new tools. There's large open source communities that are all organized via the cloud online. That allows us to move the whole industry forward so much faster than, let's say, in a pre-networked era when people might just be doing research in a bubble somewhere.
Yeah, I think the access is a key point. You want to get the largest group of people you can using this interesting and new technology. And very few people are going to have, a quantum computer in their basement or out in their garden shed. But they can have a router that talks to one, in their basement or garden shed, and maybe come up with interesting new algorithms or new solutions for things that we haven't even looked at yet, protein folding and other medicine stuff. So I think broadening the access will be a big enabler for some, hopefully, really interesting ideas.
And building on that, even, we did a large project with Hyundai. They already use classical resources in the cloud to train computer vision models for self-driving cars, for example, recognizing hazards or road signs, right? And there's some exciting opportunities potentially for quantum computing to make that process of training those models more efficient, more accurate, more resource efficient. And you already have all your data in the cloud. If you already have these pipelines, these large ML pipelines, et cetera, in the cloud, being able to plug in and just start experimenting with, what if I used a quantum computer to speed up this step? What does that look like? I don't have to build all this infrastructure because I've already got it. I've already have the whole data pipeline in the cloud. That's a huge value add that the cloud brings, that folks already have their production data, their production workloads. They're ready to experiment with new technologies.
And will allow for hybrid architectures where you combine, quantum and classical compute.
Completely.
Exactly. And there is another aspect too, because quantum can provide so much accurate data, much more precise data. All these AI models can benefit from a new source of data that we don't have available today because we don't have that capacity to see that clear. So, and it's a perfect match, as you mentioned, with the training and inference models in AI, because those are models or calculation methods that use high dimensionality, which is perfect for quantum computing. So.
Danielle, you actually touched on was going to be the last question, really, to kind of flip the question around to say, how quantum is going to potentially affect the cloud. So, any further thoughts to kind of round out the conversation for folks? What are some other things that quantum, just things that are just potentially be born out of quantum that might be part of potentially reshaping, how we understand, use, and operate with the cloud?
I can say it again, we have quantum as a technology. We impact every aspect of, how we do things today. Yeah. And including, the internet, how we do everything through digital media, through connectivity. So and we'll open horizon that we don't see it yet. So it will be a profound change, and I'm very hopeful. I think we will achieve amazing things.
Totally. I got into quantum computing because I do believe it can bring about a better world on so many levels. Because, the technology really is, broadly speaking, is going to do two things, right? It's going to make certain solutions potentially cheaper, faster, higher quality. And kind of more excitingly, it's going to help us solve problems that are unsolvable today. And that technology immediately being available on the cloud for everyone is just incredibly exciting. Compared to, if you think about the birth of computing, these resources were extremely localized, extremely unavailable. As the cloud scales, we'll see workloads that use a combination of classical computers, GPUs, and quantum computers, as we were talking about. We need tooling that manages these heterogeneous workloads. This will just unlock totally new use cases. And so I think of it not as like the cloud will be reshaped by quantum, but rather, overall civilization is going to have a whole new tool in its toolbox, just like when we discovered we could use GPUs to build these large AI models. That has literally created a new economy, right? But it's still just running through the cloud, through the network, right? That fundamental building blocks haven't changed. We've just unlocked a new capability.
And I would say it'd be very hard to imagine quantum adoption without cloud. At scale.
Yeah, because few people are going to be able to build their own quantum computers, and you've already, you need, as you said, you want the data there, and it's already there in the cloud because you're doing your pipelines or you're doing your LLM stuff already. So yeah, I agree. The cloud will hopefully enable more quantum use, and vice versa. People say, oh, well, I don't have to buy a computer. I can buy a slice of one. And, the whole cloud premise. So I think the two are very synergistic.
And we can think really big, if one quantum computer can do so much, imagine, a network of quantum computers, work in parallel, what we can do with that. So.
Well, definitely interesting to see how the symbiosis of quantum and cloud kind of further evolves as the technology, particularly in quantum, gets further built up and proven out. All right, listen, Daniella, James, Matthew, Rich, you've been fantastic. I appreciate you being available for the show today. Thank you so much.
It's a lot of fun.
Thank you. That is on exactly.
You can find the Das Won't Hunt podcast on Podbean, Spotify, and other popular podcast platforms.